From the graphs of y equals f of x and y equals g of x shown below, perform each of the following function operations. Functions that are written explicitly in terms of the dependent or output variable, typically y, can easily be written in what we call function notation. As an example, let's consider the equation y equals 3x minus 5. Note that the y variable here is isolated or by itself. For function notation, the dependent variable is replaced with a letter or symbol that represents the function, followed by the independent variable, typically x, in round brackets. An example here, instead of y equals 3x minus 5, we'd write f of x equals 3x minus 5. In this case, we're calling the function f. Function notation allows to easily show the input values that correspond to the output values. As an example, we could write f of 4 equals 7. This means that the point 4, 7 is on the graph of y equals f of x. Note that x equals 4, substituting that in to 3x minus 5 gives a y value of 7. Note that we can also substitute other expressions as the input value into a function. First, consider part A, f of negative 3 plus g of 8. For f of negative 3, we have to find the y value when x is equal to negative 3 on the function y equals f of x. That corresponds to this point right here. Note that the y value here is 6. We then have to figure out g of 8. This is the y value for the g of x function at an x value of 8. In this case, we have a y value of 2. We then have a total result for f of negative 3 plus g of 8 of 8. For question B, this time we're multiplying, but we do the same process. For f of 2, we look at the function y equals f of x, and we go to x equals 2. We end up with a value of negative 6. We then have to find g of negative 7. Again, we look at g of x, and we go to x equals negative 7. Here we have a y value of 2. We multiply those, and we get a result of negative 12. For part C, this time we're dividing. We have to find f of negative 4. Again, this is the y value on f of x when x equals negative 4. In this case, we have y equals 4. And then we divide this by g of 6. Again, we look at y equals g of x at x equals 6. Again, we have a y value of 4. Our result then, 4 over 4 equals 1. For part D, we want to find c, which corresponds to an x value, given that f of c equals 4 and g of c equals 2. Note that in this case, we're actually given the y values, and we have to figure out the corresponding x values. First of all, from f of c equals 4, we can see that possible values of x where the y value is 4 on f of x, we have this flat region, which corresponds to anywhere where c is less than or equal to negative 4. We have this point right here, which corresponds to approximately negative 2.2. And we have this point right here, which corresponds to c equals 8. Next, from g of c equals 2, we want the y-coordinate for g of x to be 2. This occurs at c equals negative 7, at this point, which is at c equals 4, and finally at c equals 8. In order for both f of c equal 4 and g of c equals 2 This happens at c equals -7 and 8.